Good morning, everybody. I am just setting up and we will be ready to go. Today we are talking about percentages still, but at the same time we are going to talk about the next chapter, algebraic thinking. Since the topic of percentages, in my opinion, crosses over very nicely into algebraic thinking in a quote unquote natural way. Let me show you what I mean by that. Just check this. Okay, so let's zoom this correctly. All right. Okay, so we're still talking about percentages, and I don't have an exercise I want to look at right now. I have an example. Now, I will start by saying I'm hiding it at the bottom here because there's a typo in there. I just want the question. I don't want to look at the rest of it in the book. There is a typo. If I look at this bottom example, an item costs $200 during a 10% off sale. That's what I want, really. I don't want anything else. $200 during a 10% off sale. So 10% off results in a price of $200. The question is, what is the original price? What was the original price? So I have the information to find that, but it's sort of backwards. Usually I take a percentage decrease in this case from an amount, the original amount, and then I get a result. Now I have the result. I want to know what was the original amount. So let's give this some structure, and let's say question mark in a box is going to be my symbol to represent the original amount. I know it's a number, I just don't know what that number is. So I'm going to use question mark in a box as the sticker hiding the number, and I just can't peel it back, but it's there. Then I have the relationship between these three things, in that the original price gets decreased by 10%. What is the calculation? Well, it's a decimal number in front from my base 1 down by the decimal version of 10% times the original price, the quantity, and that results in 200. So my equation, my calculation doesn't change. It's just that I don't see all the numbers in that percentage calculation. This would have been the second one we listed. No, last one, third one, decrease, decrease. And I have the answer as well. So I have this mathematical sentence that represents the information that were presented to me in words. So a large portion of this, if not all almost, is just a translation between languages. I had everything in words. This is sort of this uh, picking of a symbol and what it's going to represent is sort of my link between the two languages. And then I have my mathematical sentence here, which we call an equation. It has an equal sign in it. But it has all the same information. Now I can look at this and say, This is a multiplication sentence. I have my unknown symbol in the wrong spot. I want it alone so I can see what its value is, how to calculate it. So I rewrite this to a division sentence, and it'll be like we've done before with the decimal number conversion to fractions. Very similar. And that then tells me what the value of the question mark is. Let's do it in the chat to see what it is. 200 divided by 0.9. And we get question mark in a box is 222.22, and we'll round it. So then I can wrap it up and say the original price, which is what my question mark in a box represented, is, I'll say here, approximately $222.22. There was some rounding involved. So I have this four-step process. 4 steps. First step is my link between the two languages. I'm just giving myself an opportunity to keep track of the unknown numbers. They're there, there's information about them, but I don't know what they are. So I pick any symbol that I feel comfortable with to represent them and keep track of them. Then comes my translation into a mathematical sentence, an equation. Then I look at that equation and I rewrite it to a point where I can see how I can calculate this unknown number. I then calculate it. And then because my original sentence, or my original problem was presented in English sentences, I finish by phrasing my answer in that original language. So we'll always look at these 4 steps when it comes to word problems. All right, so the use of a question mark in a box, it's not that strange. We've seen it in the decimal number conversion. Getting this mathematical sentence might be the most difficult, the translation aspect. And then it's just rewriting multiplication sentences to division sentences according to what I need. And then, of course, I just wrap it up. I already have the answer. All right. So sticking to the percentage topic, let's see what examples we have. We have a few. So let's see here. Exercise 15.8. The town's budget is now 3 million. That is 25% more than what it was last year. What was last year's budget? Now, sure, you can take a guess and check approach, I guess. But if the numbers aren't very convenient for us, in general, it's just not going to be a good time. And I might get stuck and take a long time to guess the exact answer. So guess and check is not something I want to rely on anymore. But I luckily don't need to if I just understand this translation aspect. So I have a budget that is sort of the new amount, I'll call it. The new amount is 3 million. And then I don't know the original, last year's budget, original amount. So this year, ooh, my writing is terrible. And last year, I don't know what this is. And I do know that from original to new, if I can call it that, is an increase by 25%. They might not use the word increase. They say 25% more. It's the same thing. So I have all the information. I just need to translate this. So my question mark is right there. I just need to make it official and say question mark in a box is going to represent for me the last year's budget. And I'll make it easier in millions so I can just focus on the 3 and not add that many zeros to it. It's unnecessary. Okay. So this was, let's call it step 1, because those 4 steps will never change. Then I need a way to translate this, but I've gotten all the information out of the word problem already. I just have to look at this last one and see, well, I know what the calculation is for increasing by a percentage. The original amount is adjusted by a percentage, 25%. It's increased, so that's from my base 1 up 0.25, because that's the decimal version of the percentage, times the original amount, which is what I represent as question mark in a box, and they tell me that is 3, because I'm going to do everything in millions. So that's my translation. So really all we're trying to get used to, I think, is maybe translating this to a full mathematical sentence. And it doesn't matter where the unknown portion sits. It's a number like anything else. I just happen to have a sticker on top of it, so I can't see the number itself. That doesn't mean it behaves any differently. Then my third step in this process is quote unquote solving the unknown symbol, the unknown number. But in a very basic sense, it's really just rewriting to a more convenient version of this sentence. This is a multiplication sentence. I don't need to think about algebra at this level. I can do it even before the word algebra is introduced. It's a multiplication sentence. I'm used to rewriting this to a total of 4 different versions. 2 multiplication sentences, 2 division sentences. The division sentence is going to isolate either one of these, which is what I want, to be able to see what or how to calculate my unknown number. But there's no real work that I do here. There's no deep insight that's new. If I have my translated sentence, an equation, then the answer is just going to follow from that. There's not much I need to worry about. And we can calculate that. Let's do it. Where is my mouse? There it is. 3 divided by 1.25. And we get 2.4. Now I just want to wrap it up. Because the original question was in English, it's nice to just wrap things up and say what your answer is in the original wording. So the last year's budget was 2.4, and now I can say, oh, the units were actually millions of dollars. And there we go. Don't overthink it. Don't overthink it and say, oh yeah, but I remember equations and they were very complicated. No, on a basic level, it really doesn't have to be. I am simply translating the given information into a mathematical sentence. And that sentence, when I look at it, in this case, I can rewrite it to different versions. I pick a version that more clearly shows me how to figure out the unknown number. And of course, depending on where that unknown number sits, what I'm going to look for, the version that I'm going to look for is going to be different. It depends what the sentence looks like. But I want to, from personally, my opinion, is that if I think of it as a translation issue more than anything else, it becomes easier to focus on what needs to happen, and it's not as mysterious anymore. I could translate the given information into another language. Maybe you want to translate it into French. You can totally do that. That's not necessarily going to help me figure it out. This mathematical language has certain aspects, properties that help me figure out technical problems, which is why I choose it. But I can translate to any other language too. It doesn't change what I'm doing. And then it becomes a matter of just learning the language, just like I would any other language. And it's not any stranger than that. So it's just a matter of time to get used to this new language. Exercise 15.9. One school had a decline in enrollment of 12%, and now it has 352 students. How many students were there before the decline? So we again have a before and after situation. Exercise 15.9. Now I like to just extract the information. We have a before and an after situation. Just get an idea of what they're giving me, what they're looking for, and so on. So after I have 352 students, it's a decline of 12%. So I decrease by 12%. What was it before? So again, I have the third type of percentage calculation, that I'm decreasing an amount by a percentage. I don't know what that amount is, but that doesn't change the fact that there is a number there. So I'm going to start by making it official. Now I can pick another symbol here, of course, but I'll choose question mark in a box, and that's going to represent the number of students before. The number of students before. And I want to write a sentence that's detailed enough so that someone reads the question, someone reads the sentence, and they understand what my symbol represents. So that was one. I'll number it again. Now I want to translate this information into my mathematical language. Now, sure, it's not a language that stands alone as nicely, so I like to have other words around it to make it more readable, but it doesn't change the fact that it's a translation issue. So it's a decrease of 12%, which means I'm going to go down from the base by the decimal version of 12%, which is 0.12. Whoops. Down from 1 will be 0.88 multiplied by the initial amount, which I can represent, and I get 352. Now for now, our examples are all very similar. Of course, it's not going to stay that way, but I just want to get used to how to view this. Now I look at this, ooh, it's a mathematical sentence, yes, multiplication sentence. And so I can rewrite this to a version that I prefer, which is going to be one of the division sentences, which allows me to find the value of the missing number that I represented as a symbol. Let's see what it is. 352 divided by 0.88. And we get, 400. Oh, that's very convenient. 400. And then I just want to wrap it up and say before, or let's say it like this, there were 400 students before the decline. And we're done. 4 steps, no more, no less. All right. So yes, we try and repeat things a lot in these early stages to get us used to the 4 steps, get us used to how to look at these things so that when it gets more complicated, the 4 steps will not change. The translation aspect of this will not change. Just maybe the mathematical sentence might change because the information is different. I translate it to something that looks slightly different. But the essence of how I approach this will not change. Things can get incredibly complicated. We won't see that, of course. But even in very, very, very complicated situations, those 4 steps are 4 steps. It's still the same. And people forget that and they get caught up in the complexity. No. Let's see the next one. A company announced that it is increasing its workforce by 15%, which is 30 workers. How many workers will be in the workforce after the increase? All right. Now, this one, let's see. I will number it. Exercise 15:10. So let's see what we have here. We have an original, you might say, that is increased to a new amount. And it's an increase by 15%. I don't know the original. I want to know how many will be after the increase. I want to know that. But I also don't know the original. It's not 30. If you read carefully, and many people don't, the 15% is equivalent to 30 workers. So the fact that it's an increase in this case is it's not irrelevant, but it's not quite immediately important for me. 15% on its own is the same as 30 workers. Okay. So if I just forget this for a second, forget that for a second, and I look at 15% of the original, that will give me 30. So if I just look at the change amount, if you want to call it that, or the increase amount, just the amount that I get extra, that's 15%. And it's 15% of the original. It's always applied to the original. So I am going to focus on the original because I need that number to complete my mathematical sentence. So even though I want to calculate the new one eventually, that doesn't have to be my unknown. That doesn't have to be my symbol. It just has to be my answer in the end. When I write my 4th step, my concluding sentence, I need to present the answer. How I get there? Oh, I'll get there in whatever way feels efficient for me. And what feels efficient for me is to define a symbol for the original. So let question mark in a box represent the original number of workers. Oops, that's not an M. Whoa, get away from me. N number. Wow, what is happening right now? I'm thinking of many different things right now. of workers. Maybe I should lead by example and just focus on the step I'm doing and not worry about what's coming up. I fall into that trap too sometimes, thinking about what's coming up and then messing up the step I'm in. Very bad. So I am going to focus on this guy. Yeah, I want to know that one, but I don't care about it right now. Because based on how they give me the information, it's not quite relevant. It's not important right now. So now let's translate this information. 15% of a number is going to give me 30. So 15% decimal version of the original amount equals 30. That is my mathematical sentence. I can rewrite this again to see what question mark in a box is going to be. So yes, it's similar, but it's not the same, of course. And we get question mark in a box. Let's see what we get. I don't know what we get. 30 divided by 0.15. A nice 200. That's convenient. So now I simply have to use this to answer the question that they have. I can go double check. It's always a good idea before you write your last sentence. Double check. Am I answering what I think I should be answering? How many workers will be in the workforce after the increase? Okay. It's good to double check. So I can say after, I want to use their words. After the increase, there are, well, I had originally 200, increase of 30, so 230 workers. So this one is a little different. I definitely don't want to fall into the trap of repeating the same thing over and over and thinking everything is just going to be the same. I don't have to think. I just go through 4 steps and write the same thing every time. No. The 4 steps serve as a guide to give me some structure and work my way to the answer. Sure. But I can't shut off my thinking. I have to work with whatever information they give me. And how I'm going to proceed is going to depend on what information I have and how those pieces relate to each other and all kinds of things. That determines what I'm going to define as my unknown symbol, my unknown number that I need to keep track of. The information they give me is going to determine what my mathematical sentence is because I translate that information. Then depending on what that is, and we'll see more complicated things eventually, will determine how I rewrite it. But step 3, in essence, doesn't change. And then I just have to make sure I answer their question. Because what I'm calculating in step 3 might not be exactly the answer to the problem. It should get me to the answer pretty quickly, but it might not be exactly the same. So I try and emphasize these things because I know people just look for shortcuts. Naturally, I do too. It's not something to be ashamed of, but it's something to be aware of because it could lead me into trouble. Use the steps, know the steps, follow the steps, but I am very much guided by the information that the problem gives me. I have to work with that. All right. Sometimes it's super straightforward, sometimes it's not. And I can't go in thinking it's going to be one thing when it just isn't. I have to put my feelings aside and just look at it for what it is. But there will always be a common theme in my approach. Alrighty. let's see the last one in this grouping. It's a bigger one, so I definitely like to just map out the information before I start with step one. Let's just read the whole thing. A mayor notices these facts. The city budget last year was 25% more than the 15 million budget of the previous year, and this year's budget is 12% more than last year's budget. So this year's budget is 37, 25 plus 12% more than the budget 2 years ago. Let's analyze this situation. Now, I didn't actually ask a clear question here because I'm using this to discuss uh, the situation. So it sounds a little open, but of course, a test question wouldn't be this vague in its question portion, right? But because we are discussing it, I could leave it a little vague. Let us see what is happening here. So I have three periods, three time periods, let's say. I have last year's budget. I have this year's budget. And I have the previous year, which is the year that came before last. The city budget last year was 25% more than the previous year. So from the previous year, I increased by 25% to last year's budget. I don't know what it is, but I know the previous year was 15 million. 15 million. And this year's budget is 12% more, so that's an increase by 12%. That doesn't even look like an N. What is wrong with me? Don't answer that. We don't have time to go into that. 12% increase, more than last year. So yeah, I put question marks here, but that doesn't mean I'm gonna define a symbol yet. Just want to know, okay, they don't give me this one. And I want to eventually know, well, from the previous year to this year, what is the increase? Increase by what? He thinks, or she, the mayor, thinks that it is a 37% increase. Let's just see. So in this case, it is much more straightforward if I just focus on one step at a time. The first step is from the previous year to last year. I have three pieces, three numbers. There's the original, there's the new, and there's the increase. So let's say I'm going to put L in a box for last year. That's going to represent last year's budget. And I'm just going to have the millions in the unit, so I don't have to worry about all the zeros. So I can just call the previous year 15. If I don't have this portion here, then I have to have 15, 0, 0, 0, 0, 0, and so on. Then, if I look at that time window, increase by 25%. So from my base 1 decimal version of 25% up, applied to 15 equals my L. Actually, I'm going to put the L in here now. L with a box. I have decided. I need that as a symbol. I personally decide that, and that's what I'm going to call it. But in this case, I see that, well, there's no rewriting necessary here. Maybe I can flip it around, but I see how to calculate this L right away because it was just in that position, in a convenient position in my mathematical sentence that I don't need to rewrite it, and I can just calculate it right away. Let's do that. 1.25 times 15. And we get 18.75. 18.75. That's now new information. Now I'm doing a little step 1, 2, and 3 as part of my big question, but this isn't my final answer, so I don't have to worry about a concluding sentence until I'm completely done. Now I look at the next window, last year versus this year, and it's going to be very similar. I might want to say, let's call T in a box. Let that represent this year's budget in millions. Then I have a increase of 12% from the number that I know is last year's budget. Hopefully I calculated that correctly because I now do depend on that. 18.75 increased by 12% to get me what I called T in a box. I can call it whatever I want. Okay, so let's write the translation of this. 1.12 applied to 18.75 is going to give me this year's budget. And again, I look at it. The sentence doesn't need any rewriting. It tells me already what to do to calculate that T symbol. I'll just do it. 1.12 times 18.75. Yes, type that in right. And I get, 21. Wow, that's nice. Clean. So I have a little step 1, 2, and 3 there as well. But that wasn't the final answer that they're looking for either. I just need that. I decided I need this. It is 21 million, of course. Million, of course. $sign if you want to be very precise. Okay. So now I can look. Okay, I needed to fill in these years, I felt, to figure out what is the actual increase from the 15 million to the 21 million. That's actually, I'm trying to figure out, is it 37? I just add these percentages. Well, in order for me to be sure, I need to see those numbers because my unknown sits in the percentage. Now, I don't need to define that necessarily because I just want to see what is the percentage this year to the previous year. So I don't have to define symbols every single time. It depends on the situation. It depends on how easy the situation is. Let's say the percentage for this year, compared to the previous year, if that makes sense, is 21 over, what was the original? 15, make it a percentage, which is, my writing's terrible today, which is, let's see what it is. 21 divided by 15 times 100. Why do I think I'm going to get a decimal number? I am not. Okay. 140%. This is an increase by 40% and not 37%. So this is not the only way to do it, I'll admit that. But I'm just aiming for the simplest way to break this down in case you have no idea how to navigate this. And that often requires maybe a little more writing, and I'm okay with that. As long as I understand and can duplicate this thinking then I'd rather have more steps and more things to write. Let's just zoom out a touch. See if we can see the whole thing in one screen. That's maybe a little too zoomed out, but I'm going to go with it. So what happened here? Let's just talk about things that we learn, that we can add to our experience and move forward into other problems. Even though it might not be exactly percentage problems, I can learn from this still. So I had multiple steps, multiple windows, okay. Every single window was exactly the same procedure, really. But I wanted to figure out the numbers because the ultimate question is previous year to this year, what is the percentage obviously increase? What is the percentage change? So now, yes, another option was I could look at the change amount and then take that as a percentage of the original and I'll get 40. Or I could just do new to old and then interpret that percentage, which is 40 above the base 100. So it's an increase of 40%. I didn't need to define a new symbol here. You're welcome to. It's just going to be equal to this calculation. But symbols are, I didn't need to define this L in a box either, or the T in a box either, because as soon as I translate, it's immediately there. The, the symbol is more crucial and convenient when the translated sentence isn't clearly showing what the calculation is to find that unknown number. And I had to rewrite this a little bit like before, right? Here, the technically speaking, I have my unknown. The immediate translation of the given information into a mathematical sentence, mathematical equation, doesn't give me the value of this question mark in a box immediately. I have to rewrite it and do something. Then this strategy is very useful. In this situation, based on the information, the translation gave me the calculation immediately, and I didn't have to have a symbol that I define. It was simpler than that. But maybe I didn't know that at that stage, so I wanted to be safe. Totally fine. So it shows something else about percentages, that they're not additive in this way because they're sort of compounding. One is building on to the other. The 12% is applied to a number that incorporates the 25%. So they're sort of linked together. They're not just added separately. And the resulting change overall isn't just 25 plus 12. It's something else, and it's not as simple. But it's good to be aware of uh, percentages, and even if I conclude that, oh, okay, now percentages don't work in the simplest way possible, I'm not exactly sure, but by calculation it comes out to be uh, something that's not additive. And in order for me to see what it is, I'll have to do some stuff, sure. But at least I know that no, it's not as simple as just adding up the percentages. It doesn't work like that. And that's already something that I can take with me. I've talked to people at a bank that maybe he tried to keep things as simple as possible, um, that try to, not, he didn't try, let's say it like this. He explained things in a way that made it seem as if you were just adding up these percentages. It was a more complicated situation, but still, it's sort of the same. And I was like, whoa, percentages don't work like that. I can't right away in my head know what this average change is. It's kind of an average, right? I would have to do a calculation, but I definitely know you don't just add them up. And he didn't understand what I was trying to say. Maybe I didn't explain it very well. Because I had an experience before that tells me that they don't just add these up. It's more complicated than that. I don't know what it is without a calculation, but I know you don't do that. So that already is a important knowledge about percentages. All right, this is actually a very nice place to stop the percentage uh, topic. It wraps up our percentages. Now there aren't any examples, right? Because those exercises with percentages are mainly used to cross over into our last chapter, algebraic thinking, where it's all about, no, not this one, maybe this one. It's all about defining a symbol to help me in my translation. Then that translated sentence, for our purposes, will be an equation. How do I rewrite this equation, even if it looks more complicated, to see how my symbol is calculated? And that can then lead me to the answer. That is in essence, uh, I would say algebra. Algebra actually means something else. The algebraic thinking strategy, that this symbol that we define we'll call a variable. I don't know why they call it variable, because it's not a changing amount. That it is a specific number hiding behind this, but they call it a variable, even for this simple situation. I then have an equation that involves that symbol, that variable. I need to just understand and be sure, how can I manipulate this equation to still have the same meaning? It's a sentence, right? I can't just change sentences, they might change the meaning. So I need to rewrite a sentence in a way that is still safe and preserves the meaning of the sentence, so that when I have a version that I actually like and can see the calculation, I can then trust that answer and move forward solving the question. But we will have to leave that for tomorrow because we're almost perfectly out of time. Are there any questions on this before we pause until tomorrow? All right, we will pick this up tomorrow with our last chapter. We're so close. We're so close to the end. Hang in there until tomorrow.